Hello everyone, my name is Farkhondeh Vahdati. I am a PhD student from the Department of Architecture at xi'an jiaotong-liverpool University, and I am excited to join the SBCC conference. The title of my research that I would like to present today is Benefits Derived from a WASP, a Grasshopper plugin to design for disassembly principles in the built environment. This paper is conducted through WASP simulation in designing a traditional Iranian timber pavilion-inspired structure with a 3 meter to 3 meter footprint in a roof structure. The research question in this paper is how can the WASP a Grasshopper plugin aid the practice of DFD in the built environment? Using the 4 main principles of circular design, mainly the DFD, the authors try to find the potential aspects of the Grasshopper plugin to find the optimized solution for the aggregation of elements in the building. Here, there are some literature studies through the main keywords discussed in this paper: DFD, WASP, plugin for Grasshopper, and Iranian timber structure. For the DFD, the authors adopt 3 criteria from the 10 DFD principles in this paper. They are the aggregation process of part geometries in WASP, connection locations, and the orientation toward the building elements. On the other hand, for the DFD evaluation, there are 3 principal criteria: functional decomposition, technical decomposition, and physical decomposition. Which focuses on systematization and clustering, relational patterns, and assembly sequences, and a type of connection. The aggregation process in WASP is conducted with part geometry, simulating the assembly process by the contact surfaces. Discrete elements are connected by the defined rules and quantity of parts. Also, the modularity of elements occur by the same sections and different lengths of the element types. This figure illustrates these 5 types introduced in this paper. The structure analyzed in this paper is mainly the roof structure with no nails and no glue. The roof structure in second affairs is a wooden truss with a false cover made of wooden frames. Essential elements in WASP can be known as shape grammars. According to the literature research done for DFD, WASP, and Iranian-inspired timber structures in Science Direct and QMinCAD, the design of these basic elements occur regarding their joining and detaching behavior. The current structure is designed for a 3 meter to 3 meter area with a sloped roof from traditional Iranian houses, and this diagram formulates the main elements of this system. According to the 3 DFD evaluations, the authors tried to put into practice a mixture of these evaluations, and the discrete elements are evaluated in 3 clusters in a system. Each element is specified in its pattern and structure, and they are all in assembly sequences so that they can be disassembled sequentially. The orientation toward the building elements is by the direction of the curves set to the points on the top, bottom, and side of the elements. This figure illustrates the 3 levels of the roof structure when the bottom for all Grasshopper groups is reset and all layers are off. The aggregation of part geometries occurs via the points located in the defined and the specific parts of the elements, both in beams and the connections. The 2 connections are forwarded to their defined points by the rule grammars. The orientation of the connections toward their perimeter beam is by the defined curves following the previous points, and the specified point list command sets the disassembly steps. All the 3 criteria mentioned in DFD literature are mainly defined by 3 basic commands: geometry, points, and curves. The merge component connects the elements in an aggregation. This study attempts to answer the research question, how can the WASP, a Grasshopper plugin, aid the practice of DFT in the built environment? Since the rule is generated, all possible connections are considered, not necessarily the controlled ones. However, in this paper, they are more controlled according to the roof structure, and the rule is defined for each section. All this process done in this paper can be done by fields too. So the fields as drivers decide where to place parts in aggregation. As we always start with the highest value, proceed by the testing different possibilities of growth, and always choose the growth position that brings us to the next highest value. Repeating this process can generate complex aggregations that apply well to our target. Thank you for your attention.